the A out.
That is great. Okay, well, okay. Let's balance. Now, the first thing, these first four are kind of easy because they're singles, just elements. That makes it easier for a reason because when you balance one thing, it doesn't screw up another element. Let's take a look here. KF. Is that carbon? KF. This is the secret recipe. Potassium, chloride, carbon. I bet it is. What? KFC? Kentucky Fried Chicken. Have you been living? Oh, you're a Popeye person, aren't you? Shame on you. Anyways, I don't think that is actually the secret recipe. Don't try. Anyways, when I look at this, okay, I got 1K and I got 1K. You know this, but I've got two fluorines here, so I need two in front of there. That's gonna. We know the law back and forth, right? There's no one way to do all of this. Once I do that, I'm good with fluorine. So what do we do with potassium? K. I like blue foam. Heavy brown. Yeah. Something like that. I know French. Okay. Anyways, we go back and forth. The next one is similar. I would say, look, when you have elements on the left or on the other side, and compound on the right. So, what's the logic here? I would say look at the compound, well, just stop. Okay. Talk to me. I'll bring someone up here so you talk. Okay. You're not sure, but go ahead and try. Okay. This means 4 sodium atoms, 2 times 2. Yeah. 4 sodium atoms, 2 oxygens, 2 oxygens. By the way, we can only balance with front numbers. Okay. You can't, I don't like showing mistakes, but for example, for this one here, I could not go like this and then say, okay, now that's good, and I could just put 3 in front or something. I can't alter those. Only front numbers, right? That's disappearing ink. That's wrong. Very sure. So, speaking of that, what do we have to do here? Think about the compound. Somebody else other than Lori did. You know, step on the sideboard, right? So talk to me. What are we looking at? I see a problem here. Okay, good. Then we got 2 times 3, 6, Na. Why don't say it's shallow? I'm lonely. I like to sing. Well, good, but literally say that to me. Get it on paper. You guys might be rusty with this, but hey, okay. Now, strontium, nitrogen, strontium nitride. Okay. I see the N2s at the moment are okay, but the strontium's fine. Can we do this? This one might be simpler than the others. Yeah, okay. Someone's not willing to be out. Someone's signaling. 3. So that takes care of it, right? Okay. Now, by the way, I got to. Anybody else within in the last 2 minutes? Did I have? Were you before I started the recording? Yeah, okay, I couldn't remember. So are really difficult and interruptive, and I've told you this before. I think you stay coming in. I'd rather have you come in late than not at all. Okay, back and forth. These are more complicated because the minute you touch a compound on one side or the other, it screws up another element. Yeah, we'll see. So let's start thinking. At the moment, I scan first. Sometimes it's 1, 1, 1, 1, 1, right? The test, 1, 1. O, 1 and 1. H, there's 2, O. There's 3. I know on the left, and I can talk to you about my thought process. I know on the left, the water, the H2 part of the water, tells me that hydrogen has to be an even number on both sides. We got an even number in a single one. Yeah. Okay, now we've got multiple of 2 for hydrogen, so, and I totally get it. So we've got 2 hydrogen, that's 4. And then what you were saying was, I think it works, we're going to try it and see. 2 here, so 4 hydrogen. Now it screwed up the oxygen, but does it work? Yep, it does. 2 oxygens in the water, 2 oxygens in the AOH, naming practice, potassium hydroxide. More about that. Okay. Now, I just have to readjust the potassium. I'm doing these off the top of my head. If I make an arithmetic error, it happens. Stop. They're not too shabby, but you can see what I mean. There's more to it when it's not just elements. Okay, I'll do the same kind of scan here. This is what my thought process is. First of all, iron and iron. 2. I might be thinking 2, but let's just take a look at anything else too. You know how I was saying with the water before I needed even numbers of hydrogen? I've got O3 and O2. So this won't be as simple as, and this isn't going to work. That won't help me too much because I need an even number of oxygen to make this work because oxygen as an element comes in picture 2. So what does it tell me about the iron 3 oxide? The right hand side, Fe2O3. What must I at least try? Yeah. I'm going to try it my 2. I highly recommend you do these in pens. Because you're going to try things sometimes and then scratch it out. Try it again. If you're doing it in pen, somehow be neat so I can read your answer. Yeah. I want to give you marks. Okay, so now I at least have an even number of oxygen. Now, and I'll tell you a little tip. Leave that to last because I like to balance that last because it doesn't screw anything else up. If I adjust any of the other compounds, you're adjusting 2 elements at a time. Okay, so leave any lone elements until last. You could work out water right now. I do know. So FeS2. What do you notice? Now I know I can balance the Fe with 4. Then that's going to screw this up a little bit. So, yep. Okay, so I'll do the 4 like I suggested. You suggested an 8. Let's just see here. I'll slow down my thinking. Say, yeah, that's 8S, 8 salt. Okay. I've got the iron 4. Yep. So it's now time to count up my oxygen. 2 times 3. So that's 6 plus 2 times 8. You guys following the arithmetic? 6 plus 16 is 22. So I need 11 times 2 for oxygen. Is that correct, though? I do make arithmetic errors. I don't. You I come back in 5 years, I won't know 2 plus 3. I won't know a proton from a neutron. The way this aging thing is going. Anyways. Now this one is the most common. On these, I'm looking for everything's a compound. No elements, so it's not the same. But I do look for some things that are the same on both sides. Notice there's a group of SO4 and a group of SO4. Now, I point this out, they're sulfate. They don't actually separate them. I'm going to treat the sulfate as if it's one thing. I'm not going to count it as 4 O's and 1 S. I'm going to count it as SO4. At the moment, this SO4, this SO4 is the same. You can treat it as sulfur for oxygen, but I consider those oxygens different than these oxygens. It's kind of trapped in that package. What to do? What to do? NH4, I'm thinking when I look at this looks similar. It's not the same to NH3, but my N's in there. I've got 2 groups of ammonium. So probably 2 right here. I think I'll even put that in ink. That'll stay. So I'm back and forth. I've done something. You notice how one hydrogen is different now? Okay, so that doesn't solve the hydrogen. It must be taken up. I'm lost. What do I do next? Talk to me about sodium. Back and forth. Sodium. Na2. What can we try and maybe erase? Now remember how I said treat the oxygens in the SO4 as a package deal. I now have 2 oxygens, and I'm ignoring the SO4 oxygen. The lone, or the other oxygen, involved with this water, I need 2 of those. I don't know where this is going. Sometimes I try things and I do erase even. I've been doing these things for too long. Okay. Now it's time to count hydrogen. I think everything else is good. Checked up on. Well, I've got 8 hydrogen plus 2. 10. Well, I got 3 times 2, so 6 and 2. Right? Okay, where am I? Oh, sorry, I started talking about, yeah, I was doing wrong. Hey, 6 and 4. This is exactly what we wanted, right? See? Told you. That's my arithmetic. I'm not one of those teachers who says, oh, I make mistakes. I do make mistakes. I want you to catch them because I don't always do. Okay. Is this balanced? I'll double check it. It's complex. 2. Yeah. 2. Yeah. Good. I just counted the ages. 8 plus 2 is 10. 6 plus 4 is 10. A group of SO4, group of SO4, sodium, check. Just because they're hard and they take trial and error a bit, doesn't mean you can't do them. You can do them. Now, like I said, if you're worried, don't worry. I'm not testing you on this on Monday. I'll put it back. You're going to get lots of practice. I'll just pause this here for a second. So there's a reason why we need to name things, and we need to have that back in our heads and balance. Because we're going to take a look, and this is the actual first unit of physical science that's first portion of the chemistry unit. That's new material, types of reactions. Let's take a look at that. Only two types of organizers. Types of chemical reactions. Okay, I'll read through with you. Synthesis. Now, outside of chemistry classroom, what does synthesis mean? To synthesize something. Non-science related. Yeah. Okay, that's not science. Yeah. You're thinking photosynthesis. But okay, no, it's a similar. There's a reason why the word synthesis is used there. But I'm thinking non-science. If you were to synthesize or synthesis, synthetic, all the same. Okay. But if I said I had a synthetic diamond or something like this, it's not a real diamond, right? But it's made up, right? If you were to synthesize, you don't use the word a lot outside of science office, but it means to make, okay? To synthesize something. It's a synthesis. I'm trying to at least relate it to something, but it isn't a common word. It's not unheard of a lot. Okay. Synthesis. You're making something. Two or more substances combine to form a more complex thing. Now, in general, when I do these ABs, I'm not talking boron. There's no A element. I'm just using like X in an equation. It's like a variable. A plus B comes together. So, these are like the first equations we looked at. So two elements come together. These two elements come together. The only thing they really can do is connect, right? That's synthesis. Decompose outside of chemistry, outside of science. What does it mean to decompose? To break down. Okay. See that? It means the same thing in science. A more complex substance is broken down into two or more simpler substances. Essentially, any synthesis reaction, if you wrote it left, right, reverse, is decomposition. It breaks up into its elements. Possibly. It doesn't have to break up into its elements. So it could break up into smaller parts, and that's why I want to show you. Here's my general one. A compound breaks up into its elements, or possibly a compound. These are simpler, they're smaller. One of them is smaller. So it doesn't have to break right down to its elements. But it breaks up. Now, combustion is a type of synthesis where a reactant combines with oxygen. I think you've heard the word combustion before. Usually you just say burn, right? Okay. And in your body, the slow burning with oxygen doesn't reach fire levels. But what do you call that when you are burning oxygen in your body? What's that? You do exercise to do that. Breathing, respiration. That's to deliver oxygen to your cells, right? It goes in through your lungs. It's absorbed by the blood, delivered to your cells. Okay. We won't go into the processes, but that's like because of enzymes in the body. It doesn't have to reach those temperature levels and stuff like this that it does if you should light a candle or paper on fire or something. Now, there's two general forms. Organic compounds like in your body, or just burning a log or burning a piece of paper, gasoline, or in this case, propane. They're carbon-based elements, and it always works this way. If you see something with C's and H's, that's why I have X and Y as a number. Combining with oxygen, we're going to just assume that it's clean burning 100%. When you burn gasoline, you mainly CO2 and H2O. There's some side reactions though where you won't get that going. There's some unintended ones, like carbon monoxide giving off. There's others. We're going to assume clean burning. So this is our general equation. You notice though, the only variables are on the CX, HY, like everything else is just automatic. Plus oxygen, carbon dioxide more. You see that? Balance. Carbon dioxide more. Now, the example I give is propane. I'll tell you, those are nasty to balance, but I'll give you time. With metals, it's way easier. Just demonstrate it. And as we just saw, there's an example with magnesium plus oxygen. Now, to figure this out, though, you have to say, so magnesium and oxygen, how do I know it's MgO? Because I'm going to leave it blank. They have to come together. So I have to figure out, look on my chart, Mg is a 2 plus, O is a 2 minus. That's why they come together 1 to 1. So your work is going to be, the only thing that can happen is they come together. Then you balance it out. So you have to figure that out. Combustion with organic things is kind of easy because you know it's automatically CO2, H2O, and that's what we'll stick to in our class. Then you balance, that's the real work there. And combustion is a type of synthesis reaction. So if I ask you to categorize reactions eventually, I will. You put synthesis, but it's with oxygen. I'll give you half because you got to be the most specific answer possible. Okay? So, because it's true, it is synthesis, but more specifically, it is combustion. This is synthesis, and just the same here. How did I know it was NaCl? Because I looked it up on the table and I figured out, oh yeah, they come together 1 to 1, and then I put them together, right? And then I balance after. Okay. And so, some of them I wouldn't expect you to figure out. So, as we see here, right up the formulas, balance, classify, following reactions. We're going to do this one, obviously, these 5, the 4 on the other side of the page. So we're going to pause. You guys are going to do those. I'll give you some help. And here's your thought process. First thing is I'm giving you the word equation. We're putting everything that we've reviewed together, and then the new thing is classified. You can probably classify this one without doing the reaction. How many things do we start out with on the reacting side? It's one name, so one thing. If you have one thing on the left, automatically, what's the only possibility? What's that? It has to be decomposition. So I'm going to maybe just jot that down because I don't have decomposition. Then, if you can tell right away, go ahead. If it helps you to come out, count the balance first, you left. Don't forget. I got nickel 2 hydroxide. So it's already told me the charge on the nickel. Nickel has a symbol. I looked it up on my iron chart. Have your iron chart ready. You're going to need it. Nickel. Okay. I'm going to just do some scratch notes in my margin. I know it's Ni2 plus. This is not hydroxide though. Hydroxide is not an element. It's up in your center ion, polyatomic ion portion. I'm waiting. Somebody's going to tell me what hydroxide is. It's one of the boldest. OH minus. So here's what I'm thinking. This is what I'm saying. When I'm doing scratch work, it's not. I would never put that down in my equation. I need the compound nickel 2 hydroxide. I think crisscross. So if I have 2 plus and negative 1, what's the formula? When we put that OH in brackets, correctly. my reactant side. It's decomp, so then it breaks up into something else. Now, my scratch word. I'm going to just erase this. This is my thinking step. I don't need to write it out explicitly, but you know how you learn best. So maybe you do need to write these out. I've had a lot of practice over 30 years, so I kind of got the knack by now. Hey, yeah, oh, you really just wanted me to go, but I thought you were going to tell me that nickel 2 oxide is a match, positive 2, negative 2, so it's NiO. Water, I'm not going to do any scratch work. I know it. H2O. Water's an automatic. Now, I'm going to erase my scratch work. You can leave yours in the bars, but I mean, it's not necessary. As you get more practice, you probably won't do any scratch work. But if you continue to, that's fine. Okay. I think I have these correct. Now I just need to balance. Is it balanced? Oh, wow. So I'm going to double check your statement. And Nick, 2 O's. 1, 2. 2 hydrogens on water. 2 hydrogens. Life is a pretty sweet fruit that balances itself, right? Like Trudeau's budget, it balances itself. Okay. Continue on with things like that. I'll give you a hint on this first one. I don't know why. I'm just feeling generous today. Aluminum is an element. When I see the name of an element all by itself, it is not charged. It does not say aluminum ion. So, aluminum is not one of the 7 diatomic, it's a metal. So I'm going to just write down Al. And it's not because of that I'm going to remind you about sulfur and phosphorus. They don't come as groups, they come as groups. Sulfur is acetate. It's going to make your balance numbers pretty good. You guys can figure out what aluminum and sulfide, the ions are. The ions compound and balance accordingly. 2 things came together to form one, and it wasn't involving oxygen, so you know what type it is out of those 3 carbons. I'll leave these 2, okay? We'll take them up in about 12 minutes, about 10 minutes. I was hopeful we could take them. Okay. Let's see where you're at. Aluminum and sulfide is 3 plus 2 minus charged. So I know that they need the common. Okay. Oh, I'll try it again. Okay. A lot of people have this. So now what? Well, balancing. That sulfur looks intimidating. 8 and 3. And somebody said, you know the lowest common multiple, 24. Oh, good, great. This is a number, but 3 times 8 make 24. So I'm going to balance with the front number, right? Only front numbers. I'm going to put an 8 here. That makes this 24. This, I've 8 already. I need 3 times that. Maybe that's a tough one to start with. It's the balancing. But get in practice. Okay, now I have to balance the aluminum. I saved the aluminum for last because it seems the least complicated. So what do I put in front of the aluminum? 60. I can categorize this. 2 things come together to make 1. I'll take these up as water. Okay, nobody was stumping that. Better not be. Dinitrogen pentoxide. That's the molecule system of name. don't need my ion chart. They don't involve ions. Di, 2. Nitrogen, okay. Pent, 5. Oxygen. I didn't expect you to know what nitric acid is, so I put HNO3. Okay. On the left, I have my 5 that's kind of screwed. On the left, I have 1 plus 5 oxygens, right? 6 oxygens. Could I get 6 oxygens out of HNO3 the way it is? Yeah, I could if I multiplied it. 5, 2, okay, hear that, okay. Have I screwed everything else up, or is it dandy? It is all 1, 1, 1. Okay, yeah, 1, 1, 2. 2 things came together to form 1. Synthesis. Okay. The new thing isn't hard, it's the balancing. Nitrogen dioxide. Luckily, I'm going to have more time. Nitrogen, N. You never start with mononitrogen, that's just a N. Di, 2, so oxygen. Oxygen as a lone element, not in a compound. Dinitrogen, N2. Pentoxide. Hey, we just had that. Oh, fun. Oh, good grief. This one's brutal. Now, I know this is synthesis. Just doing the easy things first, then we balance. And I will just get down aluminum oxide, aluminum, and oxygen. Then we'll come back and see if we have time to balance. Aluminum oxide, I think, Al, this is my scratch book, I'm going to erase it. So I'm thinking this. What's the formula for aluminum oxide? Because I use lines to come up. I look those up on the chart, and you guys tell me. Formula for aluminum oxide. Aluminum and oxygen. Al2. Aluminum as an element is no charge. Simple. Oxygen is a diatom. This, remember, your compound never have a charge. Finally, something that's not synthesis. Oh, what do we call this? One thing breaks up a couple of things. I actually saved on purpose the bus. They're tougher to balance. Okay. Back and forth. I'll do this one first. The aluminum one. I can balance that in a jiffy. I need, though, an even amount of oxygen. So the left side, what do I need to do? Now I have 6 oxygen. I need 3 times 2 on the right. Oh, I made a mistake there. I need 4 aluminums. The very last, the 4th one, the last one to do. Oh, golly, this is going to take a bit of time. I know that my nitrogen, that'll be easier to fix than the oxygen. So I'm going to go with 5 oxygens on the right. I need an even number. If they all come together. Then I'll save the lone oxygen. Let's do the nitrogen. How many nitrogen? The bell's going to ring, but just wait. Let's finish it. Whoa, whoa, whoa. What do we need? What do we need? 2 times 4. There we go. So 4 times 2 oxygen. Okay, we got 10. Hey, it's balanced. So, have a great break. You got your tax dollars worth today.